we hear about artificial intelligence, digital technology, software at every place. But the car we drive, the steering is there, brake is there, wheels, a lot of things are combined in that. And we know that each and every part of that is somewhere linked with engineering, with mechanical. Today, I am having with me Ashok Kumar Jha, who is the Director of Engineering of ZF, who sits in their Hyderabad facility. And we will know that how our automotive technology have grown. I'm not talking about EV, right?
Correct.
We are talking about even the normal IC engine vehicle.
Correct.
And how technology have transformed. And I'm telling you, this is an amazing thing. So, Ashok ji, if you can enlighten us.
Sure, we'll do that. Thanks a lot. But let me first explain you the theme here. What you see, the ZF believes see, think, act. To see, you see a camera. So there's a camera, is to see that outside. Then you have a HPC Pro AI, as you mentioned, this AI part. So high performance computer to process
in the system.
In the system.
In the car.
In the car. You have this high performance computer. So from here you are seeing the object. Here you are processing it. And then what you see in this system, all the actuators. Let me tell you what actuators we are talking. ZF has the actuator which controls the vehicle motions in 3 directions. Longitudinal, so you have the various type of brakes, be it brake-by-wire system or which is dry brake-by-wire system, wet brake-by-wire system, or the front caliper or EPB. So which is the longitudinal. Then the lateral, so you have the steering system, front steering and the rear steering, what you see there. And then the vertical direction, so you have the dampers. So what we are demonstrating, see, think and act, and we provide basically high degree of freedom through technology. Let me bring you here in the context. When I say high degree of freedom, what we have invented, it's a ZF product. Actually, it's a steer-by-wire system, very modern, very fresh from the lab. Actually, what you see here, there's no mechanical linkage between your hand wheel actuator and your front axle actuator. It's connected electronically. Now, at ZF, we deal with the life of the people. It's a safety, right? It's a very safety system. Now, what would happen if electronics fails, software fails? Now, ZF has designed redundancy concept, redundancy at electronics level, software level, and also at the communication level, so that the system will behave in a certain way. Suppose in the system, imagine it's a worst of worst situation. Then you have various mode which you give you limited assistance, but you always have some assistance available to you when you're on road. So that's basically we are demonstrating. If you see the right, the brake-by-wire system, today what you see, the vehicle brakes are driven by hydraulic systems. Now the hydraulic system has weights, mechanical things. Now what is our solution is electromechanical brakes, means there's a caliper and there's a motor. You don't need those hydraulic pipes in the vehicle any longer, so that you completely eliminate the hydraulic fluids in the vehicle. You have the caliper and the motor which you actuate through our central system, and that's what you see here, cubics. Cubics is basically more like a brain. For example, in our body, we have hands and the legs, the actuator, but it's controlled by a central processing unit called mind. This is the mind of the car which control all the actuators. So this gives a high degree of freedom. When I say high degree of freedom, this system can work with the ZF actuators or the actuators from our competitors. So that's what I said. We provide the freedom to OEMs and to the end customers and also to the mankind. That's our vision.
So you're telling that this is going to be a disruptive system.
Yes.
You are going to actually remove so many existing components.
Exactly.
So you're telling that this is kind of a processing system.
Yes, high performance computer.
Yeah, so there is a computer going to be in the car.
Yes, this is this is, you see here, Pro Connect.
My one question is that what about someone is going to hack that? When we hear about computer, software, the first thing comes to mind is someone hacks it.
Exactly.
Life.
Very, very correct, and especially I show you here, Pro Connect. Now this Pro Connect, this vehicle is now connected to the cloud, right? Now, as you rightly said, when you connect to the cloud, it has advantage. You can do over-there update. So like our mobile phone, we get the new features and functions overnight. With this, you can upgrade your vehicle functions and feature, but it brings a risk. It can be hacked. And there comes our advanced cyber security concept, the 3-layer cyber security concept what ZF has implemented, which reduce and eliminate the risk of being hacked. One thing is reduce and eliminate the risk of hack, and second, if the system is getting hacked, how the system behaves in those restricted modes. So ZF design is very robust and architecture is very predictive. So even in those scenarios, the system will behave very predictable.
Now, what happens? One of the major challenges what the manufacturers, the OEMs face is shifting from one technology to another technology. There is an investment we need to make. So here, I'm understanding. So one, the weight of the vehicle is going to come again down because you are connecting lot of wires and removing lot of other mechanical things. So that is one advantage. There may be more flexibilities coming because now you are having a software. As you told that like mobile, how we are upgrading, there is new things come. The vehicle's efficiency is growing.
Correct.
But what about that, the cost which an OEM can get inside by creating new assemblies, creating new, vendor side?
So I very agree. Always two-leg solution. You have to continue developing your existing technology. Just to give you, if you see here, our solution is IBC, which is a dry brake-by-wire system. We are even further improving it because you have to work and develop the conventional technology, and also you have to innovate the new technology. Currently, as a ZF, we believe certain technology will exist for long and certain new technology will get introduced. So as an OEM, and a tier one, you have to keep investing in a right way. Nobody has a crystal ball how the vehicle will be in next 10 years. But we all know the vehicle will not remain the same. Now, how to basically predict the future? The best way to predict the future is to define the future, and that's what ZF believes into this.
And you are doing that.
And that's what we are doing it.
So I know that you are into robust systems, you do a lot of innovation, but for me, coming here and actually touching this futuristic steering is that itself, I can understand things are not going to be the same.
It will not
Tomorrow,
be the same. It
it's
will
going
not
to
be
change.
the same. It will change, and as I told you, ZF is believing into define the future, and that's what we say, that next generation mobility is now, and you have to develop the technology, and ZF is ready with our systems.
Thank you, Ashok ji. I'm
you.
sure you will be very happy when this system is on the land.
Sure, we will be very.
And I will expect you invite me for that so that I can come and witness it.
So just to tell you, this system, a lot of engineers from India has worked on the systems. As you rightly said, when the system hits the road, even we will be very proud, and we certainly will invite you.
And let's that happen at the earliest.